If I were to try to figure out what topic in mathematics people hate the most between fractions and word problems, it'd be pretty close. I think word problems would win, but fractions are not far behind. So let's take a review of this all the way up through college algebra. I have students who are struggling with this or need a refresher. So let's go through this and really make sure you get this foundation down. So 1/3, a fraction is best thought of as a slice of pie. So if I had 1/3 and 1/4 and I want to try to add these two slices of pie together, I can't. So like to say, okay, well I have two slices. Well, yeah, but they're not the two slices of the same size. They're totally different things. This slice is considerably larger. And so what we're going to do is we're going to try to turn those slices so they're sliced the same. So suppose I had over here 1/8 of a slice. So this one was 1/8, and I had 1/2. What my goal is to slice them identically so I could add them up. So I have sliced this one back. It was 1/2. I've now sliced it into eighths so that I could add them, and I now have 5 slices that have been cut into 8. So we have to have the same size slices or it doesn't make any sense. Now, how did they do this? Well, you can't just turn a 2 into an 8. What you did is you multiplied that by 4 in order to turn it into 8. But if you do it to the bottom, you got to do it to the top. Hold on, let's get to it here. Okay, so this is kind of a strange question, but so 3 fractions equivalent to 2/5. Okay, well, we could multiply, as long as we do it to the top and the bottom, we can change it into anything we want. I'm multiplying by 2 to create 10. Well, if I do it to the bottom, I do it to the top. That turns into 5/10. I could have chosen 3. If you do it to the bottom, you do it to the top. I could have chosen 5. I could have chosen anything. But the point to this is that all of these are equivalents to 2/5. I've taken the same pizza or the same slices, I've just sliced them up differently, but it's still the same amount of pizza. So I don't think this is particularly valuable, but let's say we multiply the top and bottom by 2. We get 6/10. Let's say we multiply the top and the bottom by 3. You got to do it to both. Let's suppose we multiplied them each by 4. So I'd have 12 over 20. Okay, same thing here. You can always pause the video if you want to try. Especially through this. There's a lot of slides in this section too. I'm going to get to the heart of the matter. So you could choose anything. As long as you do it to the top and the bottom, it doesn't change anything. 16 over 20. Okay, so I'm not going to do the math language here. Let's talk about what they're saying. So we're going to talk about how to reduce a fraction. So we can go in the reverse order too. We can make them with more larger slices. That's not quite the word I'm looking for. We can make it sliced more, or we can go in reverse. And so here's what I'm saying. We can reduce this fraction. Now, I think I'm going to show you a method later, but the point of this is 32 is made up of 4 times 8. 56 is 7 times 8. Couldn't we turn that in? We learned how to factor in one of the early videos. Now, I can then, if this is what 32 is on the top and this is what 56 is on the bottom, if you're multiplying, I can reduce factors. I can eliminate them. I have an 8 on the top and the bottom. I could just get rid of them and make -4/7. Now, I actually like the way they're doing this better. What you're doing here is you can see they're both divisible by 8. That's what most people see it as, and that's true. It works. But what I think is a better way moving forward in algebra is to see that that number on top is really 4 times 8, and that number on bottom is 7 times 8. And if you have a matching factor, it has to be factors. If you have matching factors, you can cancel them. So again, you can find the numbers that these can reduce down to, like if you can see two things that they divide into. Now I'm going to show you two ways to do this. One would be, I see these are both even numbers. Okay, so I'm going to divide them both by 2. Okay, now I could see they could both be divided by 3. So I'm not all the way there. I could do it again. If I divide the top and the bottom by 3, okay, I could work my way down that way. But here's another approach that if you don't see it, what we're going to do is we're going to do our tree. Okay, I'm going to do my prime factorization to show you all of the pieces that make up these numbers. Now, once they're factored, if there's a match on the top and the bottom, you can get rid of them. And so it has to be factors. You can't like just cancel this 4 with this 4 down here, of course. You can't do digits, but if you factored it, you can cancel it down. And so what I'm left with is negative 7 over 3 times 3. Well, let's put that number on the bottom back together. I get negative 7 over 9. Now, if you see a number that you can divide in here, I happen to see it, but I'm going to go ahead and do the tree just in case you don't see. So this method will never fail you, and this is really what we're going to do when we get to some harder stuff later in the book. So okay, so I have factored these in their prime factors. Well, with factors you can cancel the matches. So I've got negative 5. I'm going to put the 3 times 3 back together and get 9. Okay, yeah, now they're doing it here. So they broke. So I don't know these numbers and what you could break them down. You could see, you could have maybe figured this out in a couple of steps, but if you do the prime factorization, the matches can cancel, and I'm left with this. This is exactly what I was doing. And from an algebraic perspective, this is much more helpful than just guessing the numbers. Okay, so I'm going to break my numbers down over here. That's strange. Whoops. Well, I could have done that. Now this one's going to be a lot of work for not very much. Okay, so this one barely broke down at all. So okay, so I did a lot of work on this one. That because 23 doesn't go any farther, wasn't all that helpful. But I can cancel now a 3 and a 3, so they're gone. And now I'm just going to put it back together. So the 10, 20, I'd have 40 down there. Okay, let's do another one here. I'm going to break the numbers down. You can always stop the video, oops, if you want to do this yourself. No, 96. Okay, this one breaks down quite a bit. That's going to turn into these 4 2's. Okay, so this was quite a lot. So on top I've got 2 times 2 times 2 times 3 times 5. Okay, I think I've got them all. So now that it's factored, we can cancel our matches. That's a 3, even though it doesn't look like one. Okay, so what do I have left? I've got a negative 5 over 2 times 2 times 2 over 8. Now, we can do exactly the same idea when we have letters involved. So this 5x is really 5 times x, and 5y is 5 times y. We can cancel the 5's. All that's left is an x and a y. So what I'm saying here, variables are factors as well, if you've factored it all the way down. So this is really factored. It's 7 times x and 7 times y. And cancel the 7's. Get x over y. Here we can cancel the 3's. Okay, now let's move into multiplication here. So the first step of this is we're going to do, if you have fractions, you multiply tops times top, bottom times bottom. So top times top gets me 55, bottom times bottom gets me 84. So we'll do the same here. Yeah, there's a couple ways you could think of this. I'm just going to do top times top, you get 80. You know what? I think I should say this differently. I think what we should do here is cancel anything that is alike right from the beginning. Yeah, I think it's time to do that. So if you see, so you can cancel now anything. You can think of it now as it's become this. We're doing top times top and bottom times bottom. So these are now the numbers. So if you were back here like this, you can cancel diagonally as well. You can cancel anything on the top and the bottom because these are the same thing. So all of these numbers now could be broken down. What I'm getting at is I've broken down all the numbers on the top. I've broken down 28. Now everything is broken down, and I can cancel the pieces, the factors that match anywhere along the top or anywhere along the bottom, and I get, if my pen will work, I get -4 over 21. So if you leave it like this, you could have just like reduced diagonally. People will do it like that, but the reason this works is everything just moves over on the top is being multiplied, everything moves over on the bottom, and you can break it down. All the top factors, all the bottom factors, you can cancel any of them. So if you want to do the diagonals, you were taught that, it's fine, but I'm going to show you, because this is much better algebraically for where we're going, is to understand it like this. Okay, so I've just put them, all the numbers on the top, all the numbers on the bottom. They're all being multiplied. I can cancel matching factors. 3. Okay, I got 4, I got 16 left on the bottom. That's supposed to be a 3. All right, so if I have a number that I want to multiply a fraction, but I have a number that isn't a fraction, you can make any number into a fraction by putting it over a 1. So now I'm going to turn this, now if I were doing this one, to break it all the way down can be a lot of work if you already see. So I do want to see that 5 and 20 could just be reduced like this, because they both contain a 5. Now if you didn't see that, you could do it all the way out. Yeah, they did it here. They saw the 5 and they canceled it. Now the tops multiply, the bottoms multiply. We had an x up there, so 48x. Okay, I'm going to make this a -9a over 1. Cancel, cancel. So I've got 11 times -3a now. Now that's -33a, and it's technically, when that gets canceled, it's like there's a 1 there, but 1 times 1 is just 1. Now if you're just over 1, I don't even need to show that, because it doesn't change anything. I just make -33a. Okay, I'm going to put that over 1. Now I see that, I'm going to show this one. I'm going to show you that. Now this negative being on the second one is a little tricky. I'm just going to have a negative answer. So here's what's happening. I've broken all those down in their factors. 7's will cancel. I've got 13 times -2 is -26 and b. Now it's over 1. When you cancel something, you're really leaving behind a 1, but putting this over 1 doesn't really do anything. Alright, an important idea that we'll see later when we solve equations is that if the reciprocal of a fraction is just that fraction turned upside down, and the reason it's helpful is because if you reduced your common factors, it always becomes 1. Okay, so let's get to the point here. Yeah, I see why they're doing this. So division is best understood like this. Keep, change, flip. Dividing fractions is very difficult in and of itself. So what we do is we keep the first fraction, we change it to multiplication, and we flip it by the reciprocal. It's mathematically exactly the same thing, and it makes it much easier to work with. So keep, change, flip. Now we can multiply across the top and across the bottom. Excuse me. I'm going to keep the first one, change it to multiplication, and flip it. Sorry, a little drink of water there. We're going to keep, change, flip. Now there's nothing to factor down. There are no common factors, so I'm going to make this negative 15 over 8p. Okay, keep changing, flip. So keep, change, flip it upside down. Now we're multiplying two negative numbers, so they're just going to go. It'll be a positive. I put everything on the top and on the bottom. Now they then factored everything down. So now that they're factors, we can cancel the missing parts. Left with 3 over 2 times 2, or 3/4. Okay, now the minuses are going to, so multiplying two numbers with the negative are going to drop out of there. So I'm going to then turn this into 36 turns into this. Those are multiplication signs. This is 27. And this is 35. Okay, so I just put all the factors on the top, all the factors on the bottom. I can cancel matches if I can find them. Now, with working with these numbers, this would make this a lot faster to do this than to just keep guessing and trying to figure it out individually. And I get down to 4/15. Keep, change, flip it upside down. Okay, now my negatives are going to cancel. Now this one is really evident, so I'm going to just do it the other way you probably were first taught. Those reduce by a 5, so that's a 1 and a 3. These reduce, that makes that a 1 and a 2. Now I could have got there the factor way, but this one was just really easy to see, so I didn't want to do all that work. I've got two negatives, one time, so they're gone. 1 times 2 on the top is 2. 1 times 3 on the bottom is 3. Okay, now I know that's not a lot of fun, but those are really imperative skills that, again, I find many students, even at the college level, are really struggling with.